Hey everyone, how's it going? Welcome to the Post Pro podcast here. I'm your host, HVAC Jake, and I got Julian Finbow here as well. He's my co-host.
Hey, what's going on, everybody?
And today we got a special guest. We got my buddy Hayden. How's it going, man?
Good, good. Nice to see you guys.
Hey,
Yeah, how's it going out there?
Good. Everything's going great. It's busy. Like I was telling you guys before we started, just in the middle of tearing down a YK. So a nice job for these cold past few days to be nice and cozy inside.
Oh, for sure. Yeah, working on chillers is great. Being inside, not dealing with the elements outside, dealing with rooftops and all that stuff. So, yeah, Hayden. Hayden's got lots of experience, and I was going to pass it over to him and just kind of let him introduce himself and talk about some experience, and then we're going to get into talking about some chiller stuff.
Yeah, so this is my 21st year in the trade total. I started at York, then moved on. It was acquired by Johnson's, as you know. So I worked for them for 13, 14-ish years, and then spent the last 8 or so over at Carmichael Engineering. So, yeah, so a little manufacturer experience, and then now over at Carmichael, which is very different than the manufacturer, but we have quite a few chiller accounts, so it's been great.
we were colleagues for a brief time too, Hayden. I worked at Carmichael
Yeah,
for 2 years. I saw you one time at the shop.
I know, I know, I know.
Yeah,
You
me and
you
Hayden
were
worked at
part of the
Johnson.
project, so
Small world. Yeah, I mostly
yeah,
did construction. Well, probably half and
yeah.
half. I did a lot of industrial construction, service, and then yeah, data center construction and just like general whatever service on other stuff.
Yeah.
Yeah, me and Hayden worked together at Johnson's for quite a few years, so that's where we met and stayed friends all these
Yeah,
years. So
yeah. Now
it's
you're one of
been,
my close friends, so
yeah, no, it's been good, man. It's always fun. Me and Julian have been bantering back and forth, talking HVAC, and same with you, man. It's like we live it every day,
yeah.
and we love it. It's a great trade. So
It's been fun seeing you do the teaching role, and we get talking, and then next thing you know, I get texts and stuff the next day with all this stuff off the internet, about whatever we're talking about, and
oh yeah,
getting right in the nitty gritty of it all. So,
oh yeah,
no, it's fun. It's a fun trade. Not every day is great, but I couldn't imagine doing anything else, to be honest with you.
yeah,
So,
for sure.
uh, so
Yeah, man. So what have you been working on these days? Just chillers and tearing down stuff.
yeah, so I haven't got, normally I'd be getting to some maintenances, trying to get some jobs done. Like I said, we got a machine partway open, get that done. We're regasketing the whole machine as well. It's good time to do it. Depends on the machine conditions, but especially by about 10 years, you're going to have leaks all over on a machine with O-rings. So it's always a good time to do it when you do a rebuild, just prevent, those future leaks. So doing that, I got another job. I start on Monday. Take a pause here. 2 McQuays. I got to replace the terminals on the McQuays. They're leaking there. So yeah, just a little leak repair, and then get to all my maintenance. That's actually a relatively quiet off season for us. We've had in the past 3, 4 years a lot of work in the winter. Like, I mean, I think I did 6 rebuilds one winter, so
Wow.
that's a lot. Yeah,
Yeah,
that's a
that's quite
lot.
a few.
It was a little tough because we were getting into April to finish up, and obviously with the industrial side of things, that's late to have a machine still not ready. So
You recognize the one behind me?
I don't know if I recognize that one. What
That's
is
one that
that?
I rebuilt.
Oh, which one? Oh, is that 20 wing?
Yeah,
Nice. She's running like a butte still.
Small world. You guys can just look at a picture of a chiller and be like, "Oh
it's
yeah."
good to hear it's still running good. Me and
Yeah,
uh, me
it's
and
the
Rob
best
rebuilt
one
that
they
one.
got there. So
Yeah,
Hey,
yeah,
Hayden,
yeah, no.
on what you said about O-rings, one question is that are you, even though you're not like, say, let's say taking the oil pump off, just because there's an oil O-ring somewhere, like you'll take that connection off and then replace that O-ring just because its propensity to leak in the future?
Yeah, and especially if it is somewhere like an oil sump, because the heat really deteriorates them quicker. So you'll find a lot of times on ones on the condenser or on the oil sump, if they're really old, even if they weren't leaking, sometimes they'll actually crumble, break, kind of be
Yeah.
very brittle. So that's when you get leaks, because if any vibrations or movement, instead of the rubber being flexible, it's brittle now. So yeah, it's a good idea to do. It depends on what you're doing, and obviously the customers, want to get into things a lot. But if I do say an oil pump, I usually will sell them all the O-rings for the oil sump, like including the terminals, the sight glass, everything. And anybody, Jake knows this. Anybody who works for York knows, especially those sight glasses. They're a big leak point. Sometimes they don't leak, and then you turn the heater off. By the time it comes back on, you got oil out. So
Yeah.
it's
It's like,
definitely something you wanna do that sort of preemptively, because like they're really cheap parts, right? And you're in there, so you're spending minimal time, minimal money, and it's just gonna save loss of gas and downtime in the future. So,
Yeah, for sure. You almost kind of want to gather up like a few tiny little leaks. And, if
yeah,
say you have many small leaks, you're like, it's about time to do a regasket on the machine. You're not taking the
yeah.
compressor down or anything. You're just kind of doing all the preliminary piping and O-rings and stuff like that.
Yeah, and sometimes we're not going to get every single one, right? Like you're not going to be necessarily opening the compressor. That requires the motor down on a York and all that. So you might not do that one, but anyone you can get to, you do them, and it'll save you. I mean, I had actually machines here at Mac that had multiple leaks in a year. This is going back about 5 years ago, so we regasketed it, and it's been fine since. So
Yeah.
one more thing you said about terminals, Hayden. I was actually thinking about that this morning. I'm doing some admin posts in the HVAC Know-It-All app now, and I made my first one today, and it was about on the Copeland Hermetics, how the terminals will vent and just explode off. So are you talking about like a semi-hermetic compressor and then the terminal connections leaking when the work you're doing next week? You're talking about terminal.
yeah, exactly. So it's a semi-hermetic centrifugal, the McQuay WSC, and they have an O-ring behind them. They're like a fuse type plug, so that I'm not sure the material that's insulating obviously the electricity from going to ground. Some of them will leak through the O-ring, and I actually have at least one that's leaking through the material that's insulating. So it's coming down the center of it, right?
Yeah.
So I'm not sure how old these machines are. I'm going to say over 10 years, and I'm sure they're the originals. So, and one thing about those McQuays is the crankcase heaters run when they're not operating. They get pretty hot. The old McQuays, they had no thermostats, and they used to cook the seals. You'd have a crankcase at 180 degrees.
Oh,
The Dakin guys, they all put thermostats on them. So I started doing that with any of my older machines. Keep it at about 120 or so.
Yeah,
But
carriers.
the
I had a couple
yeah,
carrier machines that runs like 180 and everything's just smoking hot.
it cooks them. Yeah. So it is very important to have the heaters there, especially on a Dakin or McQuay, because the bearings are not held in with anything other than the expansion from the heat. So very important that you don't start one of those without them hot. But yeah, like when the machine's off, that gets very warm, and then when it's running, you have the motor cooling happening. So I mean, you might have 55, maybe even lower degree temperature on your motor casing, right? So it's insulated so it doesn't sweat. So you're going from that, then it's off. The heaters heat everything up.
yeah.
It goes to 100 and something degrees, and then you run it again. So it's really hard on things with expansion contraction. So
Yeah,
But
Yeah, for
you know,
sure.
for the most part, they're okay. But those are definitely going to be problematic over time. So
for sure.
Yeah, Julian had a couple questions actually about panel changes because I know he said he's been involved with some of that stuff. But you just recently did some training down in Florida
Oh yeah.
yeah,
and been going through that process. You want to maybe just walk us through that briefly?
yeah. So the company's called MCS or Micro Control Systems. I've installed a good, I don't even know, eight panels at least. And yeah, back in early December, I did their course, and they're fantastic. They're very open with everything. There's no locks on anything. Anyone can get the software. And the really great thing about them is their service is spectacular. If you put a panel in and you go to fire it up and you're having issues, you can pretty much get someone on the phone ASAP. Like there's no, we'll call you back in a day. They're on the phone with you. If it's something that's a little more difficult, they'll go, you set up a hotspot, go through your computer, they take control, they can see everything, like as if they were there. So we've been pushing that on customers who don't want to spend the money on an OEM panel. Um, the panels are the functionality of them is fantastic. They have as much or more than any of the OEMs. Um, the other nice thing I like about them is, say you put one in, I put one in, we got a solid state drive. Okay, great. A couple years down the road, they want to put in a VFD on the chiller. You put in the VFD, you run all the communication and wiring, and then you just send them the file and you say, we want a VFD on this, and they'll send you the file back with the VFD instead of the solid state. You load it in like that, and then away you go. You just make sure everything's set up properly.
Yeah, it's a lot
So
better
they're
than
really
right?
good. They're cheaper panel too, obviously, than the OEM, and I think they're just a great option. Um, they also are a handbell screw compressor representative. So the other thing which I really, really want to do, but I haven't had the opportunity, is say you have an old, Jake, you might remember the old, like, what are they, the YWZ, the water cooled semi-hermetic recip chillers. There'll be like two
Hmm.
recips on top.
Yeah.
You could retrofit that with two handbell screws with drives and the whole thing. And they've done it before. They have instructions. They know everything you need, and they'll help you through it with any problems you have. So
Yeah,
that's
that's
something
cool.
that sounds fun to do. I haven't had an opportunity to do that. Obviously, it's a specific customer that would have an old machine, and maybe you talk to them about doing that instead of replacing it. But no, they're fantastic. They treated us great when we were down there, and and the other great thing about them is they're not going to leave you behind. So if you put a panel in and 10 years down the road you need parts, they got you. They're not going to say, "Oh, we're that's obsolete. We don't make it anymore. You have to buy this." So they make things mostly back compatible. Uh, Everything is made down in Florida, Fort Myers, Florida. It's all tested down there. They have parts sitting on a shelf, so anybody in the industry at all right now, especially, sometimes you go call them up and it's going to be 2 month, 3 month wait for a part. It's getting kind of crazy. So if it's an emergency, I can have in a couple days, or we wait for land shipping. It's 5 to 7.
Yeah, that's pretty quick.
Yeah, they're awesome. So minimal downtime. You know, and just it's really neat stuff to play around with. So
Nice.
we definitely we don't we let the customer decide. A lot of customers always want OEM, and we have no problem doing OEM too. We'll do an OEM upgrade any day they want it. But um, to me, it's best bang for your buck. Go with an MCS, and you'll never have any issues.
Awesome. Yeah, the other thing we were talking about too was all the manufacturers. They have different units to basically start the motor. Like we got solid state and VFD and across line and all that stuff. And they have drive cooling that we've dealt with many issues with.
Yeah, Jake knows a lot about that.
So we were going to kind of talk about that because I know some of the manufacturers, to cool their frequency drives, they use the refrigerant, and I think that's great.
Carrier does that. Yeah.
Carrier and Train, I believe Train does as well. And I think it's a really
I haven't seen that.
Some of the Carrier for sure. I thought Train did. Some of the newer ones Train did, I think.
Okay.
And but some of the other manufacturers have like a drive coolant or an inhibitor in there that keeps the drive cool, and instead of using the refrigerant. And we've seen many issues with that stuff becoming contaminated and stuff like that. So yeah, we were just going to kind of briefly talk about that. So
yeah, I haven't had too much experience with the refrigerant cooled drives. We actually ripped one out of a Carrier. It's funny you just mentioned that because we were just talking about MCS. So Carrier had a huge lead time, pretty new Carrier with the new touchscreen, big lead time on the drive. So the customer had to either basically go the summer with a rental chiller or no cooling, which isn't an option as a condo. So what we did is we said, I can get an MCS here within, a week, and we'll get a Danfoss external air-cooled drive, and then we'll have the electricians basically run the wires over. And so that's what we did. We swapped out the panel with an MCS, swapped out the drive, put an external air-cooled Danfoss in, and hooked it all up, made it work. So it was a way to get around, and I think we had, total maybe 3-week turnaround, maybe even less. So we can usually get an MCS installed within a couple days.
Yeah, that's pretty good.
Yeah, so it was customer, it was getting quite warm out. Everyone was antsy, but customer was happy. We were able to get them going, and it would have been a lot cheaper than repair plus a rental. So
it's good you mentioned the rental chiller as well too. I've talked to people out in the field, and they just don't even know that's an option. And some of my students that are coming through or whatever, and I've told them about this situation before. I'm like, yeah, you can rent the chiller, comes on a flatbed, and they just run some pipes and hook it up. So, they
have rental rooftops as well. Rental rooftops. Yeah, I've seen them. They just run these big giant flex ducts and sit the rooftop outside. Similar idea, right?
Mm-hmm.
Yeah.
I have been part of that, unfortunately.
Yeah.
The pandemic houses. Remember those ones?
Oh yeah, no, that was for that one, Jake, was for the field hospital in Hamilton that had
that's what it was.
I did maintenance there for a summer. That was until they took it down, and there was never any patients. But also when I worked for Carmichael Hayden, we had the Esso refinery contract, which was like the safest place in the world. I remember I hit my elbow there one time and I was like, am I gonna get fired? But we had those rooftop units outside, like giant ones, and we ducted them into the office when a retrofit was being done. So now I remember.
Yeah, so there's a lot, I'm sure there's I don't know what else you could need, rooftops, chillers and stuff, but it's always we run into things where you just can't do anything about it. I don't know how rooftops, I know we've done, even this year, we had a rooftop that was vandalized at Cogeco, and our guys spent the weekend basically prepping the rooftop, and I believe the next week they got a new one lifted up there and put on the place. So usually you can get them pretty quick, but if you happen to run into a situation where you can't, so it's an option for people to think about and consider. And the customer, I think most, I know with the chillers, you can pay them to install it. We typically do the install ourselves. They just drop it off. But you can pay them to do the install. There can be a little bit of work on the install, depending on the situation. I mean, we've had to cut pipes and have welders come in and put in T's so we can tie in, but at least it's there in the future. If they ever need it again, it's ready to go. So
Yeah, for
Not my
sure.
favorite work. Not my favorite work to do, but when you have a hospital, it's a necessity. So
Oh yeah. And then when the rentals come and they don't work,
yeah,
Yeah.
exactly.
got to service those too. I've had
Actually,
that a couple times.
it's a big problem with the rental chillers. When I was at York JCI, I actually did a lot of the maintenance and work on the rentals that I can't remember. There's a company that used us. So
Gal Power or
it,
not? Different company.
no, I think it was like Echo or something or Eco, but I don't know
I
if they're
can't
still
remember the name.
around. This is actually back, a long time ago, so over 10 years ago. But yeah, they see a lot of beating, driving up and down a highway, banging on the back of a trailer, and typically you almost always are running into something when you get them there, right? So
There is companies like Ontario and Quebec. One's called Gal Power, and I actually had a student when I taught at Mohawk. I remember his name because the comedian Russell Peters, his name was Peter Russell.
yeah,
But they provide
yeah,
the chillers, they install them, or they'll help you install them if you want to do it yourself. They'll come back for service if there's failures. So they're actually like an all-encompassing company. So I've had good success with
yeah.
them because they actually take care of their equipment.
Yeah, we've used Gal, and I will say, for the most part, we had the equipment show up in good condition. Um, Sometimes just little things you can't, you'll have a condenser fan motor or something, it's blowing a fuse, and if you don't need it, you just disconnect it. But they've actually been pretty good. Most of their stuff showing up in good condition. So, but yeah, actually, we got a little off topic there. Going back to what Jake was talking about, the coolant in these things. Jake's an expert on the Yorks. He's had a lot of issues there. I'm not sure why, but JCI has changed their coolant multiple times after years and years of using what we just call by the color the pink stuff. They moved to different formulas, and I mean Jake can speak to some of the issues when he was at JCI with the first, I guess, iteration of the blue stuff.
Yeah,
But
the pink inhibitor was okay. There wasn't a lot of issues. There was a little bit of a microbial issue they were dealing with, but it was
I never had that. I
nothing
never
more
had the
than just having to
microbial
clean
issue.
it out. I think it might
Yeah,
have been for some chillers that were sitting. Um,
gotcha.
they didn't change it out for a couple of years, or down in
Yeah,
the States too. A lot of these chillers run year round, warm climates and stuff like that. So a little bit different, but um,
yeah,
I only had a few that had a microbial issue, and then they changed the composition and went through a couple different trials, and um, yeah, it was not as successful as they hoped to be, or whatever. So we were having issues, and we had to clean out the drives and use like a conditioner and a cleaner and everything approved for the drives, because you can't just throw CLR down there and hope for the best,
yeah,
because you're dealing with drive inverter plates and stuff like that, and you don't know what could happen there. You don't
yeah,
want them to eat away at the metal on the IGBTs or anything like that. So we were using the appropriate stuff. We were managed to clean up most of them, but it was crazy that York went that way, where they were using this inhibitor to cool the drives down, where it's something that can go pretty wrong. And if there's a leak, you could have this stuff leak out into the drive. I've seen it where the coils inside of the drive leak and take
Spooky.
out
yeah,
a drive. But like you said, carriers got refrigerant cooled ones, so they're just running refrigerant through a pipe through a coil, and there's no issue with contaminants because the refrigerant's clean. So I think
yeah.
that's like the best option.
Yeah, like I haven't had a lot of experience with those, so I couldn't tell you any downfalls with using the refrigerant. I mean, for the most part, we didn't really have many problems with the coolant. The big issue was the formula, and for those that aren't so familiar, like maybe we should clarify. So the condensing water goes through a heat exchanger, and it cools the coolant. The coolant is what runs through the drive, and they have an air coil that cools the air, and it also runs directly, like Jake said, through the base plate and the IGBTs. And on the new machines, they actually run through the inductors. So they use giant inductors, reactors, right? York calls
Yeah,
them
that's
inductors.
on like the new YMC square chillers.
Yeah, correct. So that's all cooled by that fluid. So it's really, really, really important to keep those drives cool. And I've seen a lot of less experienced techs that don't clean their heat exchangers. Clean your heat exchangers. You just clean them. It's gonna pay dividends over the years. You're not gonna have a failure. And when those things fail, they don't just kind of fail, they blow up, right? And it's tens of thousands of dollars, to replace. So sometimes you can't avoid that. I'm a York guy, but I'll tell you those drives, at least the older ones, lots of problems with them eventually blowing up. But if you keep them cool, I mean, I've had some out there that are 10 plus years and they're still going. So I think that's a big thing. And just keep an eye on your drive temps. It's condenser water through there too. So if you foul up your tubes, you could be fouling up your heat exchanger there. So it's all something you want to really keep an eye on those newer machines. But like what Jake was talking about is from the opposite side, which we usually don't have to worry about, is the inhibitor side. It should be always good to go. Put new inhibitor in every year, but for whatever reason, that reformulated inhibitor caused more issues. And you can't really get in there and clean it very easily. So cleaning that problem up is not easy.
Yeah, and another Johnson company, Frick, who you guys would know, they make
Yep.
industrial screw chiller packages. So
Yep.
I've been part of that too on the 4160 machines that have the Viper drive. So their
Yep.
glycol or inhibitor, whatever the formulation is, cooled, like for the heat
Yep.
sink. So we drained it. I think it was just for maintenance, and refilled it with new inhibitor. Because the weird thing is, I never really researched this, but inhibitors and glycols actually lose their propensity to be a good heat transfer fluid over time, and they degrade in their capability to transfer heat. So that is why it's
Interesting.
maintenance procedure. Yeah.
Mhm.
Yeah, we always just did our inhibitor yearly. It's just, something we did. That might be overkill, but I don't think it's probably not that much money to do, so it's well worth it.
Yeah,
Um,
maintenance on these chillers is like a key thing to keeping them last long, right? There's not a whole lot of maintenance things to do on it, but like you said, with the coolant, if you change it every year, and we're going to talk about brushing the tubes in a minute. Julian had a question about tube fouling and stuff like that, and even just checking electrical and a few other small items. Just doing that annually is going to make your chiller last longer because it's all these little things that add up
yeah,
to causing problems, right? If you don't clean the heat exchanger for the inhibitor on the drive and that drive overheats, it's going to blow up. It could be catastrophic. So, little things like that. Like if you don't brush your tubes on the condenser side, because it's a water cooled chiller, right? We got refrigerant on the inside, water going through the tubes, and you got water going up to a cooling tower that's potentially picking up dirt and debris and losing your heat transfer, then your chiller capacity is going way down. So.
yeah, yeah. It's not only just length of the life, but the capacity. Exactly. You're wasted energy if you're not rejecting that heat. So.
Yeah. So on that note, Hayden, what is tube fouling and why is brushing tubes the best job in HVAC?
Well, it's not a bad job. People complain about it. I have no sympathy for it. You're warm, you're cozy, you got your headphones in, you listen to music, podcasts. I mean, I've punched more tubes than I could ever count, but it's really important. And I guess depending on what type side of the system you're talking on, we typically do every year we do our condensers, and every 5 years we do the evaporators. So evaporators closed loop. Typically, you don't have any issues, but we still need to do those as well. And most guys will do them in conjunction with the relief valves because those are also 5 years. So we do relief valves and evaporator tubes and eddy current testing actually. So, but to answer your question, tube fouling, it's basically a buildup of anything on the tubes that's going to restrict or insulate the tubes from exchanging the heat. That could be something like dirt and debris, sometimes like a biological type growth. that usually can be removed with a tube brush. It could also be scaling, which is a much worse condition, and that will not be removed by a tube brush. So it's just like when you boil water in your kettle and you get that buildup, that's scale, and that will build up on your tubes if your chemical isn't on point. Then you're looking at a flush of some sort of acid, and that will get rid of it. So we don't really want to do that. You can never get 100% of the scaling off without taking a little bit of the metal. So if you're acid cleaning a lot, you're reducing the thickness of the tubes and essentially reducing the lifespan of that chiller. So super important. Unfortunately, we don't do chemical, and we by the time we know, it's too late, right? So we're looking at a machine that has heat exchange issues, and it's probably too late at that point if it's scaling.
Yeah, it's good
So
to have
super
a good chemical company that takes care
big
of this
time.
equipment and have a good relationship with the techs or the techs or
Yeah.
whatever. And yeah, make sure that they're on top of it, because if it gets away, even on the chilled water side, because it's a closed loop, if the chemicals aren't great, and you start getting some algae in there, or
Yeah.
rust or debris or anything in there, then that could be a problem. But I've seen many problems on the condenser side, because the cooling tower is outside,
Yeah.
and it's warm in the summer. It's picking up dirt and debris, and it doesn't have enough stabilizer in there or the proper chemical composition. And I've seen chillers plug up mid-season, and
Yeah.
our cooling season is only 6 to 8 months. So 4 months in, you get a fouling of the tubes, and that's a problem. It should
Yeah.
last at least 6 to 8 months and get you through the season with one brush.
We had that site you're very familiar with, McMaster Hospital, Mumsy. That's exactly what happened. Everything was going great there. They fouled up really bad last year. They acid cleaned. I had great approaches, and then it was from June to July. It was huge difference. And now, you're getting up there with temperatures. Your water might be coming back from the tower at 80 degrees maybe, and you can't reject the heat. Your head pressure goes up, and basically we had the chiller eliminating itself. We couldn't get it to 100%. It would limit itself at 85 or something due to head pressure. So and in the middle of the season, what are you going to do? You're going to take that machine down, like they limped it through, and now we're dealing with it in the off season, Unfortunately, most of my sites, we don't do the chemical. We don't hire another company to do the chemical, so it's up to the customer to do that. And it's up to us to explain to them the situation. But at the end of the day, if they choose to do the same thing over and over again and have the same issue, I can't control that. So I know you had that same problem there. So
Yeah, because me and Hayden worked at some of the same facilities, and even we worked together at Johnson Controls, and then he went to Carmichael, but everything goes out to tender. So
yeah,
every few years they kind of rotate these big sites around, and we
yeah,
get to see the same equipment again. So I dealt with a lot of issues about 5 years ago, and even recent with fouling tubes and stuff like that. And they changed the water coming in from the city, and they were adding phosphorus to it, and we were having all sorts of issues with things. And I think it's sort of kind of resolved itself now, but
yeah, I don't think they're doing that. Haven't for a while. I don't think that's the issue we're having, because I haven't seen it. Would be more across the board issue.
Yeah.
So not really having that. This is a very site specific issue, right?
Mm-hmm.
I'm sitting next door at the university right now, and these tubes are perfect, and they've been perfect for the 8 years I've been here for Carmichael. So they're just very on top of things here, but next door are a little different. So it's a whole thing, right? It's a chemistry, and things happen too out of their control. Like if you don't have proper bleed off, maybe by the time you find the solenoids not working, it's got some stuff in there. So, but a good chemical guy is very valuable. Save you a ton of probably saves you a ton of energy too, right? And it's all
Oh, for
money.
sure.
So
Oh
if you're
yeah,
running a plant like this plant has, three 2,000-ton machines and two 2,500-ton machines. So every little bit counts when you're cooling an entire university.
for sure. Oh, yeah.
That's the thing too about big equipment, right? Like you could get away with maybe not cleaning the condenser on your ductless split at your house. I know I do. But if you have a giant piece of equipment, all of those imperfections are amplified. So you lose
Yeah.
tons of energy. And yeah, as far as when I worked at Simcoe, we used Chem Aqua as a contractor to come in, like a water specialist. They'd sell you the products, test the water, give you recommendations, whatever you want to do or don't do
Yeah.
yourself, clear cool with. Um,
Yeah,
and
you got to just go with whoever you trust, and then sometimes over the years the techs change and that can get tricky, but once you find someone you trust, like in our condos, we use the same people. So
Yeah.
yeah, good.
So we're getting close to the end here, but I had one more question. Actually, a student asked me yesterday, and I thought it was a really good question because I mentioned I work on chillers, and he said to me, he's like, "What's the first thing you should know about chillers?" And I was like, "Well, that's kind of a loaded question." And then I thought about it for a little bit of time, and I was like, "You know what? I got a pretty decent answer." I said, "Most of the time, it's not the chiller that's the problem. It's something auxiliary around the chiller that's a problem. Whether a pump has failed, or you got a flow issue, or your tubes are fouled, or your condenser cooling tower fan has tripped, or something like that. There's something going on. And then if it is a chiller issue, it's typically an electrical issue. There's not many
yeah,
issues that happen around the actual refrigerant side of things. I mean, there still is, but
yeah,
more or less just come up to that chiller and check everything around. Have an open mind and look around the chiller plant, make sure all the auxiliary things are working. Because, most of the time it ends up being something like that. So,
yeah. That's actually that's a good question. I think that's a good answer. You know, so many times you go on a call. I remember when I was starting out and I'd be apprentice and you're nervous going on the service call. And yeah, more times than not, it's a bad flow switch, or like you said, the pump's off, or plug strainer, all that stuff, right? And as an apprentice, you're like, oh, I know what to do. I've cleaned strainers before, so it is a lot to do with that. And I mean, flow in general, I would say flow is so important on a chiller. I tell the young guys I work with, like these chillers, they were manufactured and they were tested and they don't show up and not run proper because of something that is a problem with the machine. I mean, maybe, right? It'd be a physical component that's not working properly, but if everything's working properly but your chiller is not making tonnage or whatever, it's external, and there's only power going into the thing and flow on your condenser and flow on your evaporator. Those are the only things external to this box that'll affect it. I mean, electrically, probably will have starter issues. That's pretty obvious, but for some reason, flow is less obvious. And I mean, we could get it. There's so many problems that you can trick you when it comes to that. And even we use a pressure drop as an indication of flow. We don't have flow meters in our truck. We use pressure drop. Well, I mean, I had a situation here a few years back where it was like we had looked like something was going on. We had a head pressure issue. You look at it, and the pressure drop was big. It was actually more. It looked like I had too much flow, right? But you have to start thinking, well, what would my delta look like, if I had too much flow and all that? Well, my delta was really large. So I had a pressure drop that was really high, indicating a lot of flow, and a delta that was really high, indicating the low flow. It turned out it was just a bunch of crap from the tower. It was all against the tubes and restricting it. So it's really, it seems simple after some years in the trade, but you know you really have to like piece it out, the different things, and put them together to sort of form a picture. And are you working on low pressure? Because generally the problems are going to mean high pressure on the chiller. If it's low pressure, you might have air in the machine. Everyone wants to go right to air. That's the first thing they do on a low pressure, but Maybe it's not. Is your pump out? Is it working? Is it pumping out? So many things. So you just have to kind of one by one take the data, write it down, and start to think,
That's
what's
good.
my delta? What's my pressure drop? Is the pump out going? And then it should hopefully get a picture of what's happening. Is it tube fouling? Is it air? Is it flow? And 9 out of 10 times, those are the issues you go on calls for, right? It really
Yeah,
is
I was going to mention about chiller logs just for a quick second too. Chiller logs
super.
are super
Yeah,
important. Every time you go in, typically you go in monthly and you
yeah,
do a chiller log. And it's basically just a log sheet that you write down all the parameters and go through. So then you can watch it and monitor it month over month. And then you can find problems like that. And you're like, oh, well,
yeah.
everything was good for the last 3 months. Now it's starting to creep away on me. Now we can start digging into something because it might not affect the chiller directly, but it'll affect the capacity. And then maybe
Yeah.
6 months go by, or not even maybe 3 months, and you're like, "Whoa, we're losing it now. Now we got to do
That
something."
can that connects back to your tubes too. Like
Oh
you
yeah,
do have conditions where from 1 month it's fine and the next month it's terrible. Something happened real bad, right? But sometimes you'll see a slip on your condenser approach, and it starts at clean tubes 2 degrees, and then you get 3 and 4, and it's slower, right? And then you can try to address that with the company or the customer, and go to their guy, and maybe they find a problem. So it might be a slower thing, but you do have to keep in mind that on a chiller with a variable speed, centrifugal, or even a fixed speed, you got vanes. All that's going to affect your readings. So your approach is going to be different on a chiller that's at 95% compared to one that's at 50%. So it's not an exact science, but if you just don't just write the numbers down and just go on, especially as an apprentice and an early mechanic, look at them and try to interpret them and see what's going on. And, ask the questions to the techs that are above you,
Yeah.
super
yeah, for
important. You
sure.
got guys that you can count on, and not always are there guys like that, you run into different ones, but get a few years in, you should have some friends in the trade that you can count on and lean on to ask questions. So,
Friends with benefits. Speaking
so
of
yeah,
else, I want to crowbar into here, Hayden. I think we talked about this in our group chat on Instagram before, HVAC police, just the three of us. Um, if you talk about that term approach, could you just do an explanation of what that is and use a water-cooled evaporator as an example, and then just relate that to a air-cooled evaporator in any other setting?
yeah. So, Jake will be the guy about the technical terms that we use, and it also is different sometimes with manufacturers. So as a
Okay.
York, we always say approach, right? We always say approach, but typically on an air cooled system, you use approach for your evaporator and split for your condenser. So when I say approach on a chiller, it'll be approach on an evaporator or condenser. But
Yeah.
essentially, what you're looking at is the difference between the refrigerant that's either condensing or evaporating, so your saturation, and then your outgoing water or air temperature. That's all you're looking at. So, technically, should it be called approach on the condenser if I'm looking at a YK or a YT or any centrifugal? I'm not sure. Jake's probably a good guy to ask that, but for whatever reason, that's what we say. So that's going to tell you your heat exchange, right? That's
Yeah.
really giving you an idea of how close are we getting, and I think that's where the name approach comes from. How much are we approaching the saturation temp?
Oh,
So I
okay.
I
think
think York has a different term for it, though. I can't remember off the top of my head what it's called, but I think it's the small temperature difference or something like that.
so. Yeah. Actually, you're right. So small temperature difference is what they use on the condensers. Yeah. But when you're talking to guys, I've never heard anyone say small temperature difference.
No, but when you look at it on the screen, you're just like, it's
It
approach, so
says
you write
small
it down.
temperature.
It's
All
funny.
the silly things we do as techs, right? We just I don't know. We have funny names or different names for stuff. But yeah, you're right. It does have the small temperature difference on the screen on the condensers. So, and I've never heard that term anywhere else except for on a York chiller.
Hmm. Yeah.
Cool.
So,
All right, man. Well, thanks for coming on. It's been a blast talking about all things chillers, and we'll have to have you back again in the future.
For sure.
Hopefully,
We
we'll be
could
doing
go
this
on for hours. I'm
Oh,
sure we
I
could go on
Yeah.
hours talking things. So
and we
if we
do
do in
outside
the
of work
future,
too.
yeah, I got to go back in there.
Yeah.
We should forgot I'm working. We should definitely, if we do it again, come up with some ideas of some other topics to talk to. I think the ones we talked about today are like really good surface level stuff that you're just going to deal with. It doesn't matter what the chiller is. We didn't get into differences with screws and centrifugals. That'd be a good one, but all the things we talked about today would apply to either or, right? So
Yeah,
yeah.
for sure.
Awesome, man.
All right, man. Well, everyone
Well,
have a good day. We'll talk soon.
thanks a lot, guys.
All right.
Thanks, Hayden.
Have a good one.
Keep push pulling.
All right.
See you
Yeah.
guys.
Yeah.